Okay, so here we learn how to find inverse of a function, and this is topic discussed in section 2.7. Inverse of a function. So in class I already mentioned the general guideline for how to find an inverse of a function, and here let's go into some more examples here. And as we moving along with the examples, I'm going to verbalize the steps once again so that you can get a good hands of it. So in my example number 1, let's say we want to find the inverse, and the function here would be f of x. Find the inverse for f of x equals x plus 3. So step number 1, as I mentioned in class, step number 1, we always gonna replace the f of x notation here by a y letter. So here my equation would become y equals x plus 3, and so this is the end of step number 1. Step number 2, now in the general guideline it's indicating we need to interchange x and y. We interchange, or in daily terms it means we're swapping the position of x and y. So here in this equation, x becomes y and y becomes x. So here I have x equals y plus 1, and this is how we interchange the variables, and that's step number 2. Step number 3 now is to solve for y in the current equations. After we swap the variables, we need to solve for y once again. And so here what I have to solve for y, all we do is just simply subtract 1 from both sides. And here I have x minus 1 equals y. And here, rearranging my equations, I have y equals x minus 1. And here, checking with, so all that here, solving for y is my step number 3. And at this point, what I'm seeing here is after we solve for y, I'm seeing that there's only one expression for y. I have found only one expression for y. So that means the function does have an inverse. So my inverse now is, the last step is to decide what the inverse is. And the inverse, as a notation, f to the minus 1 power of x. So f inverse of x is assigned to be the function x minus 1 in this problem. And that's how we find the inverse. So that is example 1 of how we can find the inverse. So now looking at example 2, we want to find the inverse again. Find the inverse of, and the function I have, let's say f of x equals 3x minus 1. Okay, so in the function I have, once again, it's just a simple linear function. F of x equals 3x minus 1. So step 1, once again, as I verbalize it along the way, step 1 is to replace the f of x symbol by the y variable. So here I have y equals 3x minus 1, and that's what my equation becomes at the end of step number 1. And now step number 2 is to interchange the variables x and y. So what I have here is, in this current equation, x becomes y and y becomes x. So here I have x equals 3y minus 1, and that is the end of step number 2. Step number 3, once you finish swapping the position of the x and the y, now you need to solve for y. And here, to solve for y, I would need to add 1 to both sides of the equation, and that's going to give me x plus 1 equals 3y. And I'm not quite done solving for y yet, so I need to divide both sides by 3, and that gives me x plus 1 all over 3 equals y. Or rearranging the equation, that gives me y equals x plus 1 all over 3. And this is how we solve for for y. And once again, at this step, this is the end of step number 3. And now right at this step, let's check with the expression for y now. So I have 1y equals to simply one expression of x. And so that means we are safe to assign the inverse function f of x, f inverse of x, is going to be x plus 1 over 3. And once again, the whole reason being is that there's only one expression. There's no plus and minus in front. So there's only one expression equals to one y variable. And so now we're safe to say that x plus 1 over 3 is going to be my inverse function for my function f of x. Let's look at another example where the function grows a little more challenging. So here in my example number 3, we would like to find the inverse again. Find the inverse of, and the function that I have here is going to be f of x equals x cubed minus 1 in this function. And so once again, step 1 is to replace the f of x symbol by the y variable. And so my equation would become y equals x cubed minus 1. Step number 2 is going to interchange the variables x and y. So now I'm gonna, in my equation now, y is gonna become x and x is going to become y. So here I have x equals y cubed minus 1. And that is the end of step number 2, where we're interchanging x and y variable. Step number 3 is now to solve for y. So in my equation, as you solve for y, you need to add 1 to both sides of the equation. And that is going to give me x plus 1 equals y cubed. But here, I have not finished solving for y yet. So now to solve for y, I need to take cube roots of both sides. And technically, that's going to give me y equals the cube root of x plus 1. And notice the entire quantity x plus 1 is to be up here underneath the cube root. And so now if you rearrange the equations, switch around the equation, you have y equals cube root of the entire quantity x plus 1. And so now once again, if you check with this final equation here, what I'm saying here, I have one singular variable equals to one single, even though it might look large expression, but it's a one single expression equals to the variable y. So that means we are now safe to say that my cube root of x plus 1 is going to be my inverse of the function f. Or I'm saying that f inverse of x equals to cube root of quantity x plus 1. And that's how we find it. So at this point, it's probably a good idea to look at some of those problems where we fail to find an inverse. So now let's say in example number 4, we attempt to find the inverse again. Find the inverse and say the function that we have here is going to be x squared minus 1. So this is the function that we need to find the inverse for. So just once again, simply just carry out all the steps from the beginning to the end, and whichever the step that start giving a contradiction, that start giving an error, then we're going to stop at that step. So now step number 1 is to replace the f of x symbol on the left hand side by a y variable. So now my equation would become y equals x squared minus 1. And this is the end of step number 1. And once again, proceeding over to step number 2, I need to interchange or swap the role of x and y So now in my equation, y becomes x, and y becomes x, and on the right hand side, x becomes y. So here I have x equals y squared minus 1. And this is the end of step number 2. Everything is safe and sound so far. Now step number 3 now is to solve for x. I'm sorry, to solve for y. So here to solve for y, I need to add 1 to both sides of the equation. And I'm going to encounter x plus 1 equals y squared. And then to solve for y, I need to take square root. Using the square root property, I need to do y equals 2. Now I need to take the square root on the left hand side, x plus 1. But be careful this time. When you take the square root, there's always been plus and minus square root, indicating that whenever you take the square root of a quantity of an expression, you always need to find 2 square roots, a positive square root and a negative square root. And so now rearranging my equations, I'm going to have y equals plus and minus the square root of x plus 1. So now at this step right here, the solving step is going alright. But now let's decide which one is going to be the inverse function. So now the problem here is that this final expressions at the same time means on one hand y equals to the positive square root of x, and on the other hand y equals to minus the square root of x plus 1. And so which one of this, which function here can be treated, which one of these can be treated as the inverse function? So here in this case, we're going to say the function has no inverse for the reason being one variable y but equals to 2 different things, 2 different expressions. And so in that case, you're going to say that your function has no inverse. And this is how it's going to end.